Day 4 of 90. Today we are covering regular expressions for security. If you do any kind of log analysis, threat intel processing, or WAF rule writing, regex is something you will use constantly. We are going to build actual extraction tools, not toy examples. Let us get into it. First up, IP address extraction. The naive approach is to match digit plus repeated 4 times. That works until it matches 999.999.999.999, which is not a valid IP address. In security, false positives in extraction mean false positives in your block list. So we validate each octet, 0 through 255. The pattern is longer but it is correct. We compile it once with re.compile and reuse it across every log line. Here is the code. We open the log file, iterate line by line, call findAll with our compiled pattern, and collect every valid IP. Then we use counter from collections to rank them by frequency. The top talkers report tells you which IPs are generating the most traffic, which is your starting point for any investigation. Next, email and URL extraction. Phishing investigations start with mail headers, and you need to pull every sender address, reply to address, and embedded URL out of raw text. The email pattern matches the local part, the @sign, and the domain with proper TLD validation. The URL pattern grabs everything starting with HTTP or HTTPS up to the first whitespace or quote character. We wrap both into a function that returns deduplicated lists. I will show you running this against a sample phishing header. We find the attacker address, the spoofed reply to, and the malicious URL. These go straight into your IOC database. Hash extraction from threat intelligence. When you receive a threat report, it contains file hashes, MD5 at 32 hex characters, SHA-1 at 40, SHA-256 at 64. We build 3 patterns, one for each length, each wrapped in word boundaries so we do not match substrings of longer hex strings. CVE identifiers follow a predictable format, CVE-4-digit year-4 to 7-digit ID. One more compiled pattern. Our extract_x function runs all 4 patterns against any block of text and returns a dictionary keyed by type. Feed it a threat advisory and it pulls every hash and CVE reference automatically. This is the foundation for automated IOC ingestion. Timestamp normalization. Security logs come in syslog format, ISO 8601, Apache combined format, and a dozen others. Correlating events across sources requires normalizing all of them. We define a list of tuples, each holding a compiled regex and a striptime format string. Our normalize function tries each one until it finds a match, parses the timestamp, and returns an ISO 8601 string. Now every log source speaks the same time language. This is critical for timeline reconstruction during incident response. SQL injection detection in WAF logs. Your WAF captures raw request payloads. We build patterns for the common injection techniques, or 1=1, union select, command injection through semicolons followed by drop or delete, and time-based blind injection through sleep or benchmark calls. We also catch inline comment obfuscation. Our scanner reads each line of the WAF log, tests it against every pattern, and flags the first match. The output is a triage list, line number and the suspicious payload. Named capture groups make the structured extraction self-documenting. Instead of match.group 3, you write match group dict and get a dictionary with keys like timestamp, host, user, and IP. One more critical topic, RDoS, regex denial of service. A pattern like open paren a plus close paren plus has catastrophic backtracking. If an attacker controls the input, they can craft a string that forces your regex engine to run for minutes on a single match call. Before you deploy any pattern in production, test it with adversarial input and measure execution time. If it takes more than a couple seconds, rewrite the pattern. Use atomic groups or possessive quantifiers where your engine supports them. Compile every pattern you reuse. Re.compile pays for itself. After the second match call, and in a loop processing millions of log lines, the difference is measurable. That wraps up day 4. Tomorrow we will take these extraction patterns and feed them into structured data pipelines. See you on day 5.